Okay, so back to, we filled in the blank with, when the variable is on both sides, we're going to collect them on one side or the other. Then I asked you to start looking at that first one and decide what should we do first in that one. Anybody have a suggestion? What would be a good move to make first, Cody?
Add the opposite.
Add the opposite. Okay, so you want to change the left side of the inequality or the right side of the inequality? Which one has to be renamed?
The right side of the inequality.
Yeah, the right side of the inequality, it would be nice to rename that. I gotta do some calibrating here before we can get started. It's not cooperating with me that way either. So what would that right side look like now? What would the expression read? If we're gonna rename negative 2x minus 6. Go ahead, Cody.
5x plus 1 is less than or less than negative 2x plus negative 6.
Okay. So we're renaming just the right side of our inequality because it had subtraction, and that helps us sometimes be more successful with it. Okay? Okay, suggestion for the next move we could make. Noah?
Add 2 to both sides.
Add 2 to both sides. Why would we add 2?
Because negative, it's a negative 2, so
Where's there a negative 2?
on the left side. Negative 2x.
Negative 2x. Okay, so we have to add 2x to both sides. Is that what you meant?
Yeah.
That's what I thought. Okay, but I was, going to make you say it. Add 2x to both sides because we have variable terms on both sides, so we're going to get them on one side or the other. Looks like Noah's just said, you know what, I want to move the negative ones, and because it's always nice to work with positives. What would be another good reason why it would be a good choice to add 2x besides the fact that we get to work with positives? Cody?
Because in the end you wouldn't have to switch the inequality to the other side.
Yeah, because now the x's are going to be on the left side, aren't they? And that's where we like them. We kind of like them on the left side. So that's kind of a thought process you might want to have. Now you might want to say, you know what, I like the variable on the left, let's just always move them over there, okay? So 7x plus 1 is less than negative 6. Okay, and one of the reasons that it's really important to change it to add the opposite is what common mistake students make when they don't. What happens with that subtraction sign? Cody?
It stays with the equation. It makes they when it's still a negative, they think that all the negative's going to go away, but it stays there and makes the other one negative.
Yeah, it's easy to just forget about it, move the 6 down and say, you know what, it's not important. But it is. It's only not important when the addition sign's there. So, okay, what's going to be our next move? Make a good choice here. Don't create any more work for us than we need to. Make a good choice. What would be our next move? Julia? Subtract 1 from both sides. Because that'll get those x's alone now, because we've got them collected on one side. So now we want to work with that side, getting the x alone. So what is negative 6 take away 1? Negative 7. Okay? And it looks like we have one move left to make, don't we? What is it, class?
Divide, both sides by 7.
Yeah, divide both sides by 7. So 7x is going to get divided by 7. Negative 7 is going to get divided by 7. We have x now by itself. Do we need to switch the symbol?
No,
Why not?
because you didn't multiply or divide by a negative number.
Okay, we divided by a positive, so we don't need to switch it. Even though we're dividing into a negative, that doesn't matter. It's the fact that we divided by a positive that means you don't have to switch it around. And negative 7 divided by positive 7 is negative 1. Do you agree with me?
Yes.
Yeah? Okay, here's our algebraic solution. And now we're going to graph it. So go ahead. I think you're pretty good at this by now. You don't really even need to pay any attention to what I'm doing. You can do it. You got this. So we're still graphing our solutions, showing the graph, showing that infinite number of solutions that there really are to this. Is negative 1 a solution?
No, it's not in the solution, but x is.
X is, well, what's x then?
X is less than negative 1. So
Any number less than negative 1 can be x, but negative 1 cannot be, can it? Okay, so anybody got questions on that one? Okay, well, how's our next one different from both that equation that we warmed up with and now this first one that we solved that's an inequality? How's this one different that says, you know what, because of this, I think this is the decision I better make? Noah, what do you think?
There's there's like 4A and then 7A on the other side, so there's one on each side.
Yeah, so we have variables on both sides, but what's true about the left side that's not true about the right side? Cody?
On the right side, you have a number without a variable, and on the left side, you don't have one. So your better choice would be to subtract 7A from 4A.
Even though we're going to create a negative, it's probably a good idea to do that because there's not, and by the way, a number without a variable. Anybody remember what that's called? What's a number without a variable called? A constant. There is not a constant on the left side with the variable term, but there is on the right. So you know what? Since that variable term is already by itself on the left side, let's move the variables to that side. So let's do a subtract 7A. Even though we're going to create a negative, we're going to deal with it. 4A take away 7A.
Negative 3A.
Negative 3A is less than or equal to 6. Next move.
Divide both sides by -3.
Divide both sides by -3. Okay, so negative 3A gets divided by -3. 6 gets divided by -3. Those -3's on the left cancel each other out. We have A. Do we switch the symbol?
Yes.
Yes, because we
Divided by a negative number.
divided by a negative, so we want to make sure we don't forget to reverse the symbol. 6 divided by -3.
-2.
-2. Okay, A is greater than or equal to -2. What do we do next? Graph it. And we have to be really careful about identifying those neighbors properly. Some of us are being a little haphazard about that still. This has to match the number line, okay? So do we want an open or closed circle at -2?
Closed.
So -2 is a solution?
Yes.
Yeah, and all the numbers to the right of it are the ones that are greater than -2. What would be a really easy number if you wanted right now to check it and see if you shaded the right way? What would be a really easy number that's in our shaded region to check with? Make it 0, yeah. Because 4 times 0 is 0, so we'd have 0. Is less than or equal to 7 times 0 is 0, so we'd have 0 plus 6. So we'd end up with 0 is less than or equal to 6. Is that true?
Yes.
Yeah, I'm feeling pretty good about our shaded region. Okay. So any questions on solving them when you have variable terms on both sides? Okay, you got this. Okay, let's go to the back side then, where we have to set up our own to problem solve. Okay, it says create an inequality to solve the following problem. If you had a choice between 2 ski ticket plans, how could you determine the number of days for which plan A would cost you less than plan B? So here's the deal. Plan A costs $45 per day and includes the lift ticket and equipment. So they're saying just pay $45, you get to go down our slopes, you get the lift tickets, and you will give you the equipment besides, okay? Plan B costs $350 for the season and includes the equipment, but if you, every day you go skiing, you gotta pay a $20 lift ticket. But not the $20 lift ticket each day. Okay, so the first thing we gotta do is we gotta decide what is our variable gonna represent in this situation. So Cody, what do you think?
I think the extra represent the dollars per day.
Okay,
Or
dollars per day, what do you think, class? Do you think X is the number of dollars per day, or do we already know that? Do we already know how many dollars it is per day? How much is it in plan A per day?
$45.
$45 a day, okay? So we already know how much it is every day. How about plan B? Do we know how much it is every day?
Yes.
It's how much every day that you go skiing? Well, no, it's not $3.50. That's a one-time fee, isn't it? But every time you go skiing, it costs you how much each day that you ski, Julia?
It should be the number of days and what you call
Well, not even that. What in the inequality we set up is going to help us determine the number of days when Plan A costs less than Plan B. So what will the X actually represent in that inequality that we will solve that will show how many days?
The number of days.
It's just the number of days. Yeah, it's the number of days that you actually go skiing. So number of days would be our X. How many days? That's what you get to choose. How many days do I want to ski? Whether you go with Plan A or you go with Plan B, you get to choose how many days you're going to ski. Okay? So Plan A, what expression could represent the cost for Plan A? So basically what we're doing here is we're showing how can we represent the cost for each of these? How will we represent how much it would cost you for Plan A? Tori, what do you think? Plan A costs $45 per day and includes the lift ticket and equipment. What variable expression, what expression could we use to represent that? Any ideas? What do you have? You got an idea for me? What would you, Calvin?
Divide 250 by 45.
Just Plan A? Does the Plan A have anything to do with $350?
No.
No, Plan A doesn't say anything about $350, so I think we'll leave that out of the picture, okay? Cody?
It says $45 per day, or per day.
Okay.
So wouldn't you multiply $45 per how many days you're going to go skiing?
Yeah, wouldn't you have to if you ski 3 days, wouldn't you take 45 times 3? If you ski 10 days, wouldn't you take 45 times 10? So what are we gonna do?
45 times, or 45x.
Yeah, there's our Plan A's expression. It doesn't cost any more than that. They charge $45 a day, and that includes your equipment and your lift ticket. You pay them $45, and everything's included. So $45 each day. Michaela?
And for B would be like plus 350 and 20x.
Okay, so let's just put that one by itself. Let's not put the plus in it, and let's just say it's $350, right? That's a one-time season pass, and then they charge you $20 each day for the lift ticket. Okay? So $350, that's a one-time thing. They'll give you your equipment every time you come skiing, but they are going to charge you $20 every day that you come skiing. So $350 plus 20x. Now, the other thing that it says is we're trying to find when Plan A costs less than Plan B. So let's write that down. Plan A is less than Plan B. That's what they asked. Determine the number of days for which Plan A is less than Plan B. So we got something that represents the cost for Plan A. We have 45x. Is less than. We got something that represents Plan B, 350 plus 20x. And now when we are done solving this, this will tell us how many days, because x is the number of days, so this will tell us how many days you can go skiing, and the cost for Plan A will still be less than if you went with the Plan B. Because no one's going to want to put out $350 for a season pass if they don't ski enough days. So we're trying to figure out how many days would you have to ski to make it worthwhile. So go ahead and solve this because you know how. You just practice that on the front. hold up on graphing it because we're going to describe this in words, okay? Did you get the same algebraic solution I did? X is less than 14. Do we agree there? So what's this telling us?
And when they hit 14 days, it will be the same for both plan A and
And if it's 14 days, it would be exactly the same. Wouldn't matter which one you went with. So if you're gonna ski 14 days that season, then it doesn't matter which one you go with. The cost would be the same. When would plan A be less than plan B? When would it be worthwhile for you to not go with plan B, pay that $350 and $20 a day? Cody?
If you plan to go 13 days or 13 days skiing or less,
Yeah. So let's write that out. If you plan, if is capitalized, if you plan to ski, you can say it one of two ways. Less than 14 days, or you can be more specific and we'll do it like Cody did. He says if you plan to ski 13 days or less, comma, plan A is cheaper. "14 days, doesn't matter. You really like to ski, you've read the Farmer's Almanac, you know there's gonna be a whole lot of snow that season. And you know you're gonna ski at least 20 times. Better go with plan B, because then plan A is gonna be more expensive at that point. Okay, anybody have any questions on a problem like this? Because when you have to do something like this in your homework, you have to do the same exact stuff we did here. You have to describe what is your variable representing. Get a good setup that will good inequality, and it helps to do things like we did. We said, you know what, how could we describe the cost for plan A? How could we describe the cost for plan B? And then we said, here's what they're asking us. They're asking us for when plan A is less than plan B. So we wrote this down. We said, you know what? Now I can just replace plan A with 45x. I can replace plan B with 350 plus 20x, and then we're ready to solve. And then in the end, instead of graphing it, we're going to write out a sentence answering the real question. Okay? So you only have 7 problems to do, but the expectations are high.